the IB exam number.
Is A like research question?
Yeah, similar to
Exam
that.
number like May 20.
Yeah, and your course. So say AAHL. You can put the year as well if you want. Table of contents, that's obvious. Table of contents, make sure it's nice and neat and tidy. Sometimes I would recommend maybe put a header or footer the whole way through it. That might be have your aim always at the top, and maybe your exam number or some of that all the way through it if you want, and have page numbers. Make sure to have page numbers in your all the way through. So headers and footers are nice, keep things neat. Introduction, for your introduction, I would imagine most of you will have some sort of picture in there of your first look at what you're doing. Don't have multiple pictures, just one, maybe two max. Just like if you're doing it on the rugby ball, put the rugby ball in, or your bike tire or whatever. Or if it's population, you can just put in some random picture. Yes?
Does page number start with a picture like all the other ones?
Here.
Starts on the table of contents.
Yeah.
Oh, okay.
In the introduction, you're talking about why you picked it. Try and put in some personal primary information. It is my rugby ball, it is my coffee machine, it is my bike, and I'm really intrigued by this, and maybe it could be used for this, and I thought that I could use this maths, what maths you're going to use here as well, from the area of the course that it is. Most of us are using calculus at the moment. Write your aim, state your aim in like 2 sentences, 1 sentence, no more than 2 sentences. So a clear aim, make sure this is clear. So I want to get the volume of the cylinder using volume of revolution or something like that. That's it. I'm trying to get that volume. Then maybe you can introduce a methodology, your step-by-step, like 1, 2, 3, 4, this is what I'm going to do. Well, usually that's done last because this is what I've done. You put the methodology in. That could take up to a page. And then if you're introducing any key terms, have them clearly labeled what each letter means in your whole thing. V stands for volume, R stands for radius, H stands for this. Any new formulas, especially that are not in your maths book, introduce them now, early on, and explain any new maths. Explain the formula, explain any new maths, explain anything that's new. If you want, use a simple example to go through how it works. Or you can just use a simple example to show what you're going to do. It works for a very simple example. Like if you're doing the wheel, you could just do that donut example that I did before. You could do it here in more detail and make it look nicer than your one. Like you can do better 3D models of a donut and say, I'm going to use this then in the body later, and I'm going to explain it a little bit less in the body because I've explained it more here. So like an explanation, I put this in as a page, but this definitely can take up to 5 or 6 pages, especially if you're introducing new maths. If it's any sort of new thing like Z, you'll probably spend a few more pages here talking about what your thing is, and if I came up with a formula, where I researched it from, cited, of course. There's lots of work to be done there. And then once you've done this, this might take 2 or 3 pages, so 2 or 3 pages probably. For most of us, we're all going to have more than a page here, I think. Alex?
Do we also describe like how we got the functions in the methodology?
I would probably put that in the body of work. You're going to go into and you're going to start with like your picture. For some of us, you're going to need to spend more time talking about getting the functions if you're using calculus. How did you get the functions? Some of us, we've explained it here because the functions were given to us from research. But some of us are going to get functions. There's a number of ways you can get functions. You can get them using transformations. So I started with a parent function x squared, and I finished off with this function using transformations, vertical shift, horizontal shift, etc. Or you can do it using regression on Desmos. So Desmos basically got it for me. And this is how I did it, step by step. I put in the points, and then I asked it to do linear regression. Here is the results of that. Put in some diagrams here as well. Or you could do something like linear algebra, where if you want to come back and do this next week, you don't have to do it now. If you're trying to get a function that has 3 variables that you can change, for instance, if you have a x minus h squared plus k. You don't know what a, h, and k are, but you do have a series of points for x and y. This is an equation with three unknowns. Maybe you could use some algebraic. This one won't work because this h is squared, but if it's not squared, let me think. If it's just, don't use that one. Use y is ax squared plus bx plus c. It's better. So if you know, so this is a quadratic, but you don't know what a, b, and c are. You want it for here. So I could say, right, I got 3 points on the quadratic that I could sub in. 2, 1, 3, 3, 4, 0. I'll sub them in 3 times. What that creates then is a matrices, yeah. You could solve it using matrices if you want to use matrices, which is within linear algebra, within the course. So that's 3 ways of getting functions, they're the main 3 ways. I can't think of anything else at the moment. So once you got your functions, explain this with good diagrams. So every time you put in a diagram or a figure, right, put a box, a nice, clear, heavy line box, make sure it stands out. Write the word figure 1.1 or whatever. If you've called body the second section, use figure 2.1 for the first one and 2.2 for the second one. And then if you're dealing with the results and you've called results section 3, call it figure 3.1, etc. So, and what it is, put a title underneath it or above it, and make sure if you have any scale in there, you refer to the scale somewhere, either on the diagram, so maybe you can make it a little bit nicer on Canva or something. You can put it in there and make it a little bit nicer, put it back into your thing. Put the scale somewhere underneath or on the diagram so you can see what the x-axis is, what the y-axis is, and there's any sort of scale on the side you need to explain. Put arrows and stuff. If you're using functions, make sure they're all individually named, so fx, gx, hx, or f1x, f2x, so on, f3x. If they're on a diagram, try and use different colors for each one. I would definitely at some stage put a table. If you have multiple functions, put some sort of table of those functions and then some sort of answer in the table. So you might have 3 columns in the table. Table 1.1 shows that all the functions listed, all their areas under the curve if you're doing that, and you have three things: what they're called, what the function is, what the area is under the curve, what bounds you've done it between, maybe the domain. Have a table like that somewhere in your main body of work. Now each person has a different body of work from then, but a little explanation underneath each thing you do. This is the table of thing. This shows this. If it has some significance, if there's one result that's particularly significant, you can clearly see that the second function gives the biggest area on the curve. That makes sense because as you can see from my diagram, figure 2.1, that's the largest. That should definitely have the largest area. Some sort of comment on the result and a what's next question. So drive it forward with, so what I'm going to do next. I'm going to do, okay, now that I've done that, I'm going to spin it around the x-axis and get this volume or whatever you want to do next. And then comment on that result and repeat. Always comment on results. Whenever you go through it, always comment on results. And yeah, always explain maths. And don't just have reams and reams of maths with no break for a little bit of explanation what's going on. Also remember, consistent rounding. Make sure you pick your rounding. Make it consistent. Use approximate equal signs at all times. So most of us are not exact equals, they are approximate equals. So there's no exact answer for any of your work over there. Trying to think what else. You probably should have a final answer then on somewhere. Always refer, each page you almost should refer back to your aim. Refer back to your aim. Having it written at the top of every page kind of reminds you to do that as well, which is why I sometimes put it in a header or a footer. Your aim, always talk about your aim of the thing and how I refer back to it and how it can be applied in everyday life or whatever if it's a particular thing. The volume of a baseball glove or whatever it is. Okay, so there's like pages and pages here. There's obviously some maths there that you'll eventually use equation editor software to do. For the moment, you're okay putting the pictures in. Try and break it up though. Don't just have A bit like what Amos showed me. He had like 6 pictures in a row. Try and do that, like picture, some writing, picture, some writing, picture, some writing. Just explaining what you're doing, commenting on result, concluding a result. Then when you come towards the last couple of pages of your whole thing, maybe a limitations section, if there's limitations on the accuracy of your work, which some of you have. Future study recommendations, or if I had more time, I'd go off and do that. And a general conclusion, once again, talking back about the aim is a good idea. Just like what I found out, what I learned as well is good. This is some overall checklist that I would do. In your introduction, have you set out a plan? So either that's in your introduction or methodology. Does your introduction explain why you've chosen the topic? So make sure you relate it to yourself. Maybe put something other than just a mathsy picture. Maybe it's a picture of you. Obviously, don't identify yourself, but a picture of you doing something. It would be good. Yeah. Is your explanation easy to follow for a fellow IB student? This is what we do when we're getting closer to the submission date. Give your explanation to somebody else. They'll read through it and they'll go, I don't know what you're talking about here. Can you explain that a little bit more? Make sure you label all the graphs. That's obvious. Make sure all your equations, when you do get to do them, are used equation editor and it looks like proper maths. I didn't talk about bibliography and citations. If you do that, put that after the conclusion section at the end and make sure it's cited the same as your EE. Do you have a conclusion? Yes, you do. What else do we want?
How many citations where do they?
Like you can do an IA with none. If you haven't cited anything and all the work is in the maths textbook, it's expected that you know it, so you don't need to cite it.
Would they mark you down?
No, for no citations, no. It's not an extended essay. It's
Do we have to
expert.
cite the textbook?
No. Have you reflected on the investigation and the meaning of your results and what your results show and how the results could be improved? Don't just arrive at results and move on. I can't understate that enough. Go through, when you get to a result, definitely write something down about what you think about it. Is it personalized throughout? So keep talking about yourself and what your aim was, and that should personalize it probably enough. And have you reflected on the result and altered your investigation to reflect your results? Now, what you could do is if you come to this stage and you're 8 pages in and you need more to do, this is where you go, right, I need to come up with more maths. I go to the textbook, I go, can I bring in related rates, optimization, kinematics, or something else where I just bring it a little bit further? Can I put complex numbers into a calculus one? Can I, if it's a statistics one, can I bring calculus in? Can I bring statistics into a calculus one? Can I do probability? Now, you guys are not too strong on that yet, but what can I bring extra maths in? Just one extra maths thing that makes sense. So I gave that example of the girl last year who drew using a spiral. It was a bit complex numbers. It was a bit, she forced it into the IA, but it made sense in its context. She did end up drawing the spiral, so therefore it showed some personal engagement. There was pictures of the spiral. She showed that she can multiply using de Moivre's theorem. You want to just go,